You know, when you look around, from the bridges we drive over to the skyscrapers that fill our skylines, our entire world is literally held together by fire and electricity. And at the heart of all that construction is arc welding. It's this incredible technology that lets us fuse metal together with amazing strength. But if it's all just about melting metal, why are there so many different kinds? Well, it turns out each one is a totally unique tool, built for a very specific job. So let's dive in and break them down.
All right, here's the game plan. First, we're going to get our heads around the basic idea of an electric arc. Then, we'll meet the original, good old stick welding. After that, we'll get into the industrial workhorses, MIG and flux cord. Then we'll check out the fine art of TIG welding, meet the real heavy-duty crew, and we'll wrap it all up by figuring out how to pick the right process for the right job.
So, what is arc welding really? Well, at its core, the principle is actually pretty simple. You're using an electric circuit to create an arc. That's basically a gap where electricity jumps through the air. This arc generates this incredibly intense, focused heat that instantly melts the edges of the metal pieces you're trying to join, and then they fuse together as they cool.
I mean, think about it this way. You're basically harnessing the power of a lightning bolt, shrinking it down to the tiny tip of an electrode, and then using that crazy amount of energy to build something brand new. It's this super powerful, super precise tool that turns a bunch of separate pieces of metal into one solid, continuous whole. Pretty cool, right?
Okay, first up, let's talk about one of the oldest and honestly most versatile processes out there, shielded metal arc welding. But, pretty much everybody just calls it stick welding. For a lot of people, when they picture welding, this is what they're picturing.
The real magic of stick welding is right there in what it calls the covered consumable electrode. See, as that metal stick melts, it's not just adding filler metal to the joint. That special chemical coating on the outside vaporizes, and it creates its own protective gas shield and a layer of slag. The two of them work together to protect the molten metal from the air. It's a totally brilliant, self-contained system.
And that whole self-contained thing, that's its superpower. The equipment is simple, it's cheap, and it's super portable. And because the shielding is made right there at the arc, it's not nearly as sensitive to wind, which makes it absolutely perfect for outdoor jobs. That's exactly why you see it everywhere, on construction sites, pipeline work, and all kinds of field repairs.
Okay, now let's shift gears and talk about the high-speed, high-productivity processes that are really the backbone of modern manufacturing. These are the workhorses you're going to find in just about every factory and fabrication shop, and they are built for speed and efficiency.
So, this is gas metal arc welding, or GMAW, but let's be real, almost everyone calls it MIG welding. The huge change here is that instead of a stick that you have to keep replacing, you've got a solid wire electrode that's fed continuously from a big spool. It's kind of like a hot glue gun for metal. The other key difference, the protective shield doesn't come from the wire. It comes from a gas that flows out of a big tank right over the weld.
And this right here is the whole setup that makes it happen. You've got your power source for the electricity, the wire feeder that's constantly pushing out the wire from that spool, and of course the cylinder that's supplying the shielding gas. It's this whole combination that allows for that super fast, continuous welding you see everywhere, from auto body shops to huge factory production lines.
Now, MIG welding is great, don't get me wrong, but it completely relies on that external gas, and that can be a real problem in windy, outdoor conditions. So some clever engineers came up with a solution. They asked a simple question: what if we could combine the continuous wire of MIG with the awesome self-shielding idea from a stick electrode?
And that brings us to flux cord arc welding, or FCAW. The electrode wire here isn't solid, it's actually a hollow tube, and it's filled with all these powdered materials called flux. And just like in stick welding, when that flux hits the intense heat of the arc, it creates the protective gas and slag you need. So let's put them side by side, so it's crystal clear. MIG uses a solid wire and needs that gas from the outside. Flux cord, it uses a tubular wire with all the protection packed right inside. Now this gives you a couple of options. Some of these wires are self-shielded, perfect for that windy outdoor work. Others are gas-assisted, where they use a little bit of external gas for the absolute highest quality welds in heavy fabrication. You kind of get the best of both worlds. You can actually see the difference in the tools themselves. See that top gun? It's for a gas-shielded process like MIG. It has that big copper nozzle to direct the flow of the external gas. But the gun on the bottom, for a self-shielded flux cord wire, it doesn't need that at all. Why? Because all the protection is coming from the inside of the wire itself. So far, we've covered processes that are really built for strength and for speed. But what about when you need absolute precision? I mean, a flawless, beautiful finish. Well, for that, we turn to the artist of the welding world, gas tungsten arc welding.
Yeah, this is what's usually called TIG welding, and it's the process you use when the final result has to be absolutely perfect. It's just an incredibly controlled, clean process that produces those beautiful, neat stack of dimes welds you see. It's a real hallmark of craftsmanship.
So what makes TIG so different? Well, two huge things. First, the electrode is made of tungsten, which has such a ridiculously high melting point that it is not consumed during the weld. It's just there to create the arc. Second, if you need to add any filler metal, you do it separately by dabbing a thin metal rod into the molten pool with your other hand. This total separation of the heat source and the filler material, it gives the welder just incredible control.
And all that control leads to some serious advantages. TIG is easily the most versatile process out there. It can join almost any metal. It produces the absolute highest quality welds with zero spatter or slag to clean up afterward, and that is why it is the go-to choice for critical applications in places like aerospace, nuclear power, and medical device manufacturing.
All right, let's switch gears from fine detail to just raw power. Now we're talking about the heavy-duty, often automated processes that are designed to weld really thick materials at really high speeds in some super demanding industrial settings.
First up is submerged arc welding, or SAW. Now this one is really unique because you never actually see the arc. The entire welding process happens buried, or submerged, under this thick layer of granular, sand-like material called flux.
Here's how it works. You have a continuous wire that's fed into the joint, while a hopper literally pours that granular flux all over the area. The arc happens underneath that blanket of flux, melting the wire, the base metal, and some of the flux itself. This creates this perfectly protected little environment, which allows for incredibly fast, deep, high-quality welds. It's exactly why this process is essential for massive jobs, like shipbuilding and making huge pipes.
And finally, we have plasma arc welding, or PAW. The easiest way to think about this one is like TIG welding's superpowered cousin. It also uses a non-consumable tungsten electrode, but the torch actually constricts the arc through a tiny little nozzle, creating this incredibly focused, high-temperature plasma jet. This jet is so powerful, it can do what's called a keyhole weld. It literally blows through the metal to create a fully penetrated joint in a single pass. It's wild.
So wow, we've seen a huge range of processes, right? From the simple stick welder you can carry around in one hand to these massive automated systems. I think the big takeaway here is that there's no single best way to weld. It is all about choosing the right tool for the job.
So let's do a quick recap. For portable outdoor construction and repair work, you grab a stick welder. For fast, clean factory work, MIG is your go-to. For heavy outdoor fabrication, flux cord is king. When quality and precision are absolutely non-negotiable, you choose TIG. And for those massive automated jobs, you're looking at subarc or plasma. Every single one has its own unique electrode, its own shielding method, and its own perfect application.
You know, every one of these processes, from the oldest one to the most advanced, plays such a critical role in our society. They really are the invisible forces holding our world together, everything from the massive structures we live in to the delicate electronics we use every single day. So when you think about the incredible range of jobs they do, which one do you think we could least afford to lose?